A semiconductor is a material with electrical conductivity between that of a conductor and an insulator. They are the foundation of modern electronics. Semiconductors come in two main types: intrinsic, which are pure, and extrinsic, which are enhanced by adding impurities. These impurities give us two further categories: p-type and n-type semiconductors. For a deeper understanding of semiconductors, check out our previous video. Link in the description below. Now, semiconductors have revolutionized our world, enabling amazing innovations like converting AC power to DC, harnessing solar energy, creating energy-efficient LED lights and displays. These are all possible just because of a remarkable semiconductor product, the diode. In this video we'll explore: what is a diode? How is it made? How does it work? Let's get started and uncover one of the most crucial inventions in electronics history. Welcome to Mr. Smart Engineering. First, let's have a quick recap. We know that current is the flow of electrons in a conductor, similar to water flowing through a pipe due to pressure differences. When we apply a potential difference, current flows from the higher potential to the lower. But what happens if we reverse the polarity? The flow direction changes because the high and low potential ends switch places. So it is clear that the current flow will happen in both directions if the polarity of the source is changed. Ever heard of non-return valves or NRVs? These one-way valves allow fluid to flow in only one direction, blocking it in the opposite direction. A diode works similarly. It's the electronic equivalent of a one-way valve. It is a semiconductor device that allows current flow in one direction and blocks it in the other. Fascinating, right? So how does a diode do this? And how is it made? A diode is created by joining a p-type semiconductor and a n-type semiconductor. We know the p-type semiconductor is rich in positive charge carriers, holes, and an n-type semiconductor is rich in negative charge carriers, electrons. Where these two materials meet, they form a p-n junction. Here, electrons from the n-type region naturally move towards the holes in the p-type region, neutralizing each other and creating a depletion region, a barrier where no charge carriers are present. This depletion region acts as a barrier to current flow inside the diode and prevents other charges getting neutralized. The diode has two ends called anode, where the positive charge carriers are accumulated, and cathode, where the negative charge carriers are accumulated. Let's see how a diode works in practice. When we connect the positive terminal of a battery to the anode and the negative terminal to the cathode, this is known as forward bias. In this setup, the battery's charges push the diode's charge carriers towards the depletion region, shrinking it and allowing current to flow across the diode. Now, if we reverse the connections, this is known as reverse bias. Here, the battery pulls the charge carriers away from the depletion region, widening it and blocking the current flow through the diode. So, a diode only allows current to flow in one direction when it's forward biased. When reverse biased, it prevents the flow. This is the core principle behind p-n junction diodes, commonly used in rectifiers to convert AC power to DC, and also in electronic protection circuits. There are also special types of diodes, like photodiodes, which generate electricity when exposed to light, forming the basis of photovoltaic cells. And then there are LEDs or light-emitting diodes that produce light when powered. We'll cover these types of diodes in detail in another video. Hope you now have a clear understanding of diodes and how they work. If you enjoyed this video, don't forget to subscribe, like, and hit the bell icon to get notified about our latest content. Thanks for watching.